Okay, so this is going to be actually just kind of an explanation of confidence intervals. The next two examples that are in the text really aren't things that they could question you on in MyLabs Plus, but it is sort of an understanding before we can get to example 4 of exactly what a confidence interval is and what it's asking. So let me see if I can kind of explain a little bit to you what exactly we're talking about when we're talking about a confidence interval. So if you think about what we just did in the first one when we did the point estimate of a population, remember we couldn't take an actual survey of the entire population because the population is too large, so we took a sample. And let's say when we calculated that first sample, it was over 50%. Let's say it was about 54%. That was the point estimate for that sample. But what if I took a different sample of 2,000 people and got a different point estimate, and that point estimate came out to be 49%? Both of those values are correct point estimates for the sample size that I took. And I could take another sample of 2,000 people and I could get another point estimate. So because of that, instead of just saying this is the value, we give an interval. So let's say I did take one estimate and it was 54, and I took another estimate and it was 49. So I just decided, okay, well, if I had one that was 49 and one that was 54, let's just kind of strike it in the middle and say 51. 51% of people think that what they pay in taxes is too much. And then I would actually go up maybe 0.5% and down 0.5%, so that I could say that they were between the range of, let's see if I go up, 50 and 52%, that between 50 and 52% of all people, of all Americans think that they pay too much in taxes. So I'm basing that interval off of the fact that what I've done is take samples, and so I know for a fact I am not going to get an exact value. You can't. Anytime you take a sample from a population, you are going to have what we call a margin of error. And that allowance, we're going to pick a value, and the allowance above and below that is our margin of error. So when we have a margin of error, we often also have what we call a confidence interval. Our confidence in our value, in our data value, depends on how wide of a margin of error are we allowing. So for example, if I say I am 90% confident that the proportion of people who think they pay tax, that their taxes are too high, is between 50 and 52%, I'm 90% confident. Then what I'm saying is that if I were to take 100 more samples of 2,000, I'm confident that 90% of those samples would fall in that particular interval. And I think that 10% might fall outside of the interval. Now, what happens is the larger the interval, the more confident I am. So if I increased my interval and I said, oh, I'm going to say that between 40 and 56% of the population think that they pay too much in taxes. Well, that's a huge interval that I'm saying that the people fall in between there. So my confidence can go way up. I could say I'm 99.5% confident that if I were to take more samples, that they are going to fall in that range because I made my interval larger. So there's like a little graphic, I think, yeah, here it is, that shows that. So you have a higher level of confidence if your interval is larger. So here's my guess. So we've marked my guess right here in the middle. And then you're going to have an interval. And if I have an interval, if my interval is small either way, then it gives me a lower level of confidence because it's going to have to fit in this little window. So I'm not real confident that can happen. But if I widen my margin of error, so I get bigger on each side, I let my error be bigger, then I have a higher level of confidence that things fit in there. So that's what confidence intervals are. Now, you should be familiar with confidence intervals, especially now. You're going to see a lot of it in the upcoming days with the election. You'll always see like poll numbers. They'll say something like that Joe Biden is leading in the polls, that he has 49% of the vote compared to, I mean, I know this is over, but compared to Bernie Sanders, 43%. And then you'll see in little letters, they put plus or minus 5%. And they're saying it could go 5% either way. They are telling you the margin of error because they took a sample. There's no way that they can question all registered voters or all registered Democrat voters. So instead, they take a sample, they question the sample, and then they attach to it a margin of error. So they don't usually tell you what the confidence interval is, but there is a confidence interval connected with it. So the next example that we're going to do on the next recording is going to be finding a margin of error and actually calculating the confidence interval. So that is all for this one. It's just explanation, nothing really to do. The two definitions are there, a confidence interval and the level of confidence. Oh, you can see there before I leave, you can see there 1 minus alpha. That's just going to be whatever your confidence interval is. So if my confidence interval is 95, my alpha is the 5%. So, and you'll see in just a minute, because we're going to be using your Z table, that those things will become important.